Now, in last lecture, we have completed how to convert or how to express decimal to rational and rational to decimal. Clear? Now, also we have completed how to represent irrational number on number line. Not only that, we completed that rational number are either terminating or recurring and irrational number are neither terminating nor recurring. Clear? And 22/7 pi is an irrational number. Approximate value is 22/7. So, this pi is irrational number, so it is neither terminating nor recurring. Okay? 22/7 is not the exact value. Okay? Now, there are 2-3 rules are, if R is a rational, R is rational number and S is irrational number. What can you say about R plus S? What can you say about R minus S? What you can say about R into S? And what can you say about R upon S? When one number is rational and another is irrational, then their sum, their difference, their product and their quotient all are irrational number. What is it? Number. This is also irrational number. This is also irrational number. This is also irrational number. Clear? But if R and S both are irrational number, both irrational, then R plus S and R minus S both are irrational. But what can you say about R into S and R upon S? Those two can be, sometime it can be rational or sometime they can be irrational also. We are not sure that they are always rational or they are always irrational. If R and S both are irrational, then their sum and difference are always irrational number. But their product and quotient, for that you are not sure. They can be rational or they can be irrational. Clear? Now, for example, see. Suppose R is root 7 and S is 3 root 7. What is R into S? It is root 7 into 3 root 7. So it is 7 3 ja 21. So it is rational. But suppose R is root 7 and S is root 5. Then R into S is root 35. So here it is rational. And here we get answer as irrational. Okay? So we are not sure about that. Sometimes the product is rational, sometimes the product is irrational. Clear? Same way. Suppose R is root 7 and S is 3 by root 7. Then R by S is root 7 upon 3 root 7. So it is 1 by 3. So rational. And suppose it is R is root 7 and S is root 5. Then R by S is root 7 by root 5. Okay? And this is, if I rationalize, I don't want square root in denominator. So I have to rationalize with root 5 by root 5. So what is my answer? Root 35 by 5. So this is irrational. In one case it is rational, in another case it is irrational. So you should remember this rule. If R is rational and S is irrational, then their sum, their difference, their product and their quotient all are irrational number. But if R and S both are irrational, then their sum and difference are irrational, but their product and quotient can be irrational, can be rational. So these are very important rule, you remember it. Now, what is the algebra of irrational number? Suppose another rule, if A and B are positive real number. These are the important concepts I am giving you, okay? So see, we have a rules for real number. Root A into root B can be written as root AB. This is the first rule. Because A and B are positive real, then root A and root B can be rational, can be irrational. But the product of root A into root B can be written as root AB. Right? Then second rule, quotient of root A by root B can be written as root A by B. I can combine them with same root. Okay? Third results, root A plus root B, factorization formula, into root A minus root B. Here also I can apply the formula. It is A square minus root B square, so it is A minus B. Clear? Suppose fourth rule, root A plus B, root A plus root B, whole square. How can I operate it as? Root A ka square, so A plus 2 times root A into root B plus root B ka square is B. And 2 root A into root B can be written as A plus 2 root AB plus B. This way I can operate. I can write the expanded form in this fashion. Same method. And fifth, A plus root B into A minus root B will be A square minus B. These are the rules for square root of any positive real number. Now see, there is another rule. If you want to see what is the most simplified answer, most simplified answer does not keep any square root in denominator. I should avoid square root from denominator. And in order to avoid square root from denominator, I have to rationalize the denominator. How to rationalize the denominator? See, suppose you want to rationalize the denominator 1 upon root A plus B is given. And I want to rationalize denominator of this expression. Then I have to rationalize this. To rationalize this, we multiplied this by, this is root A plus B, so I should multiply it with root A minus B and root A minus B. So indirectly I multiplied with 1. Something upon same something is 1. And to multiply any number with a 1 is my birthright, because 1 is a multiplicative identity where A and B are integers. Positive integers, okay? So if I rationalize, what will be the answer, new answer of this? It is root a minus b upon a minus b square. So my denominator is free from square root. This is called most simplified answer. Clear? Now, we have also learned this is called algebra of square root. Okay?